Hello, welcome back. We're going to be talking about material balances in reactive systems once again, and I am going to be talking about recycle. We have already seen this previously, but remember that a recycle is when you are going to be having some stream that you are going to input back into the system. And we're going to have, in this case, some reactants that are going to be introduced into the reactor in order to get a product. But since not all of the reactants are going to be reacting, then we are going to be feeding back from the recycle. This is in order for us to decrease the amount of raw materials that we are inputting. So this is for less costs into the process. And we can say that the overall conversion for the whole process is going to be the limiting reactant input to this process minus the output to this process over the input. And this has to increase if we have the recycle. If instead, this has to increase if we have the recycle than if we don't have it, right? And the single pass conversion is the conversion that we have when we input into the reactor, and there is going to be an output of reactant from the reactor. So this is the single pass conversion, right? And sometimes what happens with recycle, a problem that is happening is that this starts to build up. It starts to increase the amount that we have of these reactants. So in order for us to decrease and not saturate the reactor, because sometimes the reactor, if it is saturated, then it will not function that well, then we have what we call a purge. And this purge is going to be just a small amount of a stream of this recycle that we're going to get out in order for us to decrease the buildup. And the degrees of freedom analysis, well, we have the number of unknowns in the problem, as usually, but now we have to add the number of reactions in the system. Then subtract the number of independent material balances, and of course, subtract the number of relations. So now we have to add these reactions in order for us to determine the degrees of freedom analysis, because now we're once again in a multi-unit process where we have mixers, splitters, etc. So thank you very much. I hope this was useful, and see you later.